students, I'm Ms. Divya Amble, Mathematics Department, Gokhale College, Kolhapur. This is our first lecture for B.Sc. second year. We are going to learn paper number 5, which is Real Analysis first. And our first chapter is Sets and Functions. Firstly, we see that what is the set actually. So, the set is the collection of things or numbers, etc. Okay. See, the idea of set is not new to us as it is commonly used in everyday life. For example, bundle of newspapers, second number of students is also a set. Okay, sets are usually denoted by capital letters like A, B, C, X, Y and etc. If X is an element of set S, then we write this as X belongs to S. You can see this is the symbol of belongs to, and if an object Y is not an element of a set S, then we write it as Y does not belongs to set S. Okay, and this is the symbol of does not belongs to. Okay, see next, if we write the set A equals to 1, 3, 5, 7, 9, then you can see 5 belongs to A, 9 belongs to A, but number 10 does not belongs to set A. Okay, next point is finite set and infinite set. If we start counting the number of elements in a given set, and if this process of counting comes to an end at some stage, then the set is said to be finite set. And if this process of counting does not stop at any stage, then it is called an infinite set. Okay, so if the set contains finite number of elements, then we can say that set is finite. And if set contains infinite number of elements, then we can say the set is infinite. In other words, in finite set we can count all those numbers, but in infinite set we cannot count any numbers. Okay, so see next, singleton set. A set containing exactly one element is called singleton set. For example, A equals to 6. The set A equals to 6. We can see the set contains only one element, that is 6. So, the set A is singleton set. See the second example, B equals to the set X such that X minus 2 equals to 0. So what is the value of X here? You can see only number 2 is the value of X. So this condition can be fulfilled. 2 minus 2 equals to 0. So here X is 2. So 2 is the only element in the set B. Therefore the B is singleton set. Next point is null set or empty set. A set having no element in it is called null set or empty set. It is denoted by Greek letter phi or just empty bracket. Okay, so in null set or empty set contains no elements in it. You can see the example. The set A equals to X belongs to set of real numbers such that X square equals to minus 9, and we know that square of any number is always positive. So here X will be what? Phi, null set. You cannot put the value of X here. So here A is empty set. The second example is B equals to X belongs to set of natural numbers such that X square equals to 7. So we know that number of any number cannot be 7. Okay, so here the set B is empty set. Note that set 0, set phi are not empty sets. Okay, the next point is subset of a set. A set A is said to be subset of set B if every element of A is also an element of B. That is, if x belongs to A, then x belongs to B. This is denoted by A subset B. This is the symbol of subset. Okay, that is, A is included in B. So when we say the set A is subset of set B, when every element of set A is contained in set B. Okay, if A is subset of B, then B is also subset of A. Okay, note that when A is subset of B, then B is subset of A. That is, B contains A. Okay, it can be proved that empty set phi is subset of every subset. This is not okay. It can be proved that empty set phi is a subset of every set. It is obvious that every set is a subset of itself also. Okay, phi is subset of every set. Note that. And every set is subset of itself also. Means what? A is subset of A, B is subset of B, means itself is a subset of, okay, that set. So next point is proper subset. If every element of set A is an element of set B and B contains at least one element which is not in A, then A is said to be a proper subset of B. Okay, in other words, when we say A is a proper subset of B, when every element of A is in the set B and B contains at least one element which is not in A, means B contains more elements than A, then we can say A is a proper subset of B. Okay, see example. If the set A equals to 2, 3, 4 and the set B equals to 1, 2, 3, 4, you can see every element of set A is in set B, but B contains element 4 which is not in A. Then we can say A is a proper subset of B. Next example, C is equal to X such that X is a letter in the word M-I-L-E. Okay, so possibility of C here what? X is a letter in the word mile, means M-I-L-E. X, what can be the value of X? X will be M-I-L or E. Therefore, we can write the set C is equal to M-I-L-E. And here the set D is equal to X such that X is a letter in the word smile. So X will be S-M-I-L-E. So here the set D is equal to S-M-I-L-E. So you can see here C is a proper subset of set D. Okay, and this is the symbol. This is the symbol of proper subset. Okay, the next is power set. Let A be a set, then the set of all subsets of A is called the power set of A, and this is denoted by P of A. Okay, what is the power set? Power set means the suppose we have to find out the power set of A, then we have to find all the subsets of set A. Okay, see the example. If the set A equals to A and B, then power set of A, what can be the power set of A? All the subsets of set A. Okay, the singleton set A is also a subset of A. The singleton set B is also a subset of A. And we know that phi is subset of every set. Therefore, phi is also subset of A, and itself A is also subset of A. Therefore, AB is also subset of A. So here these four are the subset of set A. Therefore, these are the power set of A. Okay. See the next, equality of sets. So what is the definition? Two sets A and B are said to be equal if they have same elements. Okay. When we can say the two sets are equal? When both sets have same elements. In other words, if A is subset of B and B is subset of A, then A and B are equal sets. Okay, and we write as A equals to B. See example, if the set A equals to 3 and 4 and set B equals to x belongs to set of real numbers such that x square minus 7x plus 12 equal to 0, then it can be easily observed that A equals to B. So how? See, the set B contains x belongs to set of real numbers such that this condition can be fulfilled, x square minus 7x plus 12 equal to 0. So when we solve this quadratic equation, x square minus 7x plus 12 equal to 0, we get the values of x are 3 and 4. Therefore the set A is also 3. The set A is also contains elements 3 and 4. Therefore these two sets can be equal. Therefore we get A equals to B. Okay. Next is universal set. In any application of set theory, the sets under consideration are regarded as the subsets of a fixed set. Such a set is called universal set, which is denoted by capital U or capital X. The universal set serves the frame of reference for a particular discussion. It depends upon the ideas under consideration. If we consider the set n of natural numbers, then the set Z of all integers or the set R of all real numbers can be taken as universal set. So see, if we have the set of natural numbers capital N, then how can we choose its universal set? Its universal set must be greater than set of natural numbers. So what would be it? Either it would be the set Z of all integers or the set of real numbers which are greater than set of natural numbers. Okay. So see, what is the Venn diagram? In order to get visual picture, set is represented by the region enclosed by simple closed curves such as rectangle, circle, triangle. Such a representation is called Venn diagram. Okay, you can see the figure. So here sets A, B, C are represented by circle, and this rectangle X is universal set which is greater than all the sets. Okay, the universal set is represented by rectangular area in a plane. If A, B, C and these are the subsets of universal set X. Okay. See next, union of sets. If A and B are two sets, then the set of all those elements which belongs to A or to B or to both A and B is called union of sets A and B. So see here, it is denoted by A union B. This is the symbol of union. So see, A union B, the set A union B is equal to X such that X belongs to A or X belongs to B or X belongs to both A and B. Which elements are in the set A union B? Either this X belongs to A, X belongs to B, or the common elements. Okay, means X belongs to both A and B. All the elements in the set A and all the elements in the set B are involved in the set A union B. And it is obvious that A is subset of A union B and B is subset of A union B. How? You can see in the set A union B is also contains the set the elements in the set A. Okay, so therefore A will be subset of A union B. Similarly, A union B set contains all the elements in the set B. Therefore, B will be also subset of the set A union B. You can see here Venn diagram for A union B. So, this is the rectangle X is the universal set of both sets A and B. So, this is the sets A and B, and this shaded region This is the shaded portion will be A union B. Shaded portion is the what? Is the elements of A also, elements of B also, and the common elements. This portion also. Okay. So A union B is the shaded portion here. This will be clear by example. See, if the set A equals to 1, 3, 5, 7, 9, the set B equals to 2, 4, 6, 7, 9, then the set A union B will be what? We see here by definition A union B contains elements of A also and elements of B also. So here A union B is equal to 1, 3, 5, 7, 9, 2, 4, 6 and 2, 4, 6. 7, 9 is the common elements. We cannot repeat it in the set A union B. Therefore, what is this elements in A union B? 1, 2, 3, 4, 5, 6, 7, 9. Okay. So, see, next example is if A equals to set of non-negative integers and the set B equals to set of negative integers, then what would be the set A union B? Set of non-negative integers also and set of negative integers also. So, it is what? All the integers. So, this is the set Z of all integers. Here are the properties of union of sets. Okay. Let A, B, C be subsets of a universal set X. Then, first property of union of set is what? A union B equals to B union A, which is commutative law. Next is associative law. Means A union B union C equals to A union B union with C. Okay. Next, third property is A is subset of A union B and B is subset of A union B. Fourth, if A is properly contained in B, then A union B will be equal to what? B. In particular, A union X is equal to X and A union Phi is equal to A. If, okay, next fifth, if A is contained in C and B is contained in C, then A union B is also contained in C. Okay. Next point is intersection of sets. If A and B are subsets of universal set X, then the set of those elements which belongs to both A and B, that is which are common to both A and B, is called intersection of sets A and B, which is denoted by this A intersection B. Okay. So, if we have to find intersection of the sets A and B, then we have to find the common elements between the sets A and B. Okay. Thus, A intersection B is equal to set X such that X belongs to A and X belongs to B. Means we have to find out the common elements between the sets A and B. So, this is the Venn diagram for A intersection B. You can see here X is the universal set and A and B are subsets of X. So here shaded region is the common between A and B, means common elements between A and B, and this is the intersection between A and B. So next is disjoint sets. Two sets A and B are said to be disjoint if A intersection B equals to phi. Disjoint means separate. Okay, means there are no common elements between them. So, see example, the set A equals to 5, 6, 7, 8 and the set B equals to 1, 2, 3, 4. Then A and B have no common element. You can see in the set A and set B there are no common elements. Therefore, this is what, therefore the intersection between them will be what? Empty set phi. So here A and B are disjoint sets. So next is similarly properties of intersection of sets. Let A, B, C be the subsets of universal set X. Then as per union there are also properties of intersection. So first property is what? Commutative law, means A intersection B equals to B intersection A. Next is associative law. A intersection B intersection with C equals to A intersection with B intersection C. So next third property is A intersection A will be equal to A. Fourth is A intersection phi will be equal to phi. Because of what? The common elements between A and phi are what? Phi. Okay, so here answer is phi. Next, A intersection universal set X, therefore this answer will be the set A. Next, if A is contained in B, then A intersection B will be what? A. You can see here A is properly contained in B, therefore the common elements between A and B will be what? The set A. So last property is A intersection B is subset of A, then also A intersection B is subset of B. Okay.